So good day, ma'am. I'm Marcy and I am Dante, and today I'll be discussing about measures of relative precision for ungrouped data. So we have three. We have quartile, decile, and percentile. So first, let's know the definition. So a statistical value that indicates where a specific data point falls within the data set when compared to other data points. It is used for quantitative data that falls on some numerical scale. And also, it can be applied to ordinal values. And if you're curious about what is ordinal values, it is the values that are not evenly distributed. So we have methods that we can use to solve. We have the general method, linear interpolation, and mental execution method. So quartile of ungrouped data are the store points which reside the distribution into four equal parts. Q1 is called the lower quartile. The second quartile is the median. The third quartile is the upper quartile. And to compute the interquartile range, we just need to get the difference between third quartile and the first quartile. So we have here a word problem. So let's read. A teacher recorded the test scores of 12 students in science exam. 90, 50, 45, 60, 55, 65, 80, 75, 70, and 85. Find the first quartile, second quartile, and the third quartile. So step 1, we need to arrange the scores in descending order. So let's go back to the values that are given. So let's arrange it into an ascending order. So we have arranged the values in an ascending order. Next is we need to find the first quartile. So the first quartile is the median of the lower half of the data, which is in here. So the middle value is 55. So that would be our first quartile. Next is, let's find the second quartile. So the second quartile or the median is the middle value of the entire data set. So this is our entire data set, and we have 10 values. So the median is the average of the fifth and sixth values, which is 65 and 70 here. So all we need to do is we need to add this up and then divide it by 2. So 65 plus 70 is equals to 135 over 2. So let's divide this. So it's equals to 67.5. So this would be our median. So the next step is we need to find the third quartile. So the third quartile is the median of the upper value of the data. So the upper value of the data is from 70 to 90. So we just need to find the middle value, which is 80. So that would be our third quartile. So the final answers would be of the students scored below 67.7 and 75% of the students scored below 80. So we have another word problem. A coach recorded the running times, so it's in seconds, of 10 athletes in a 100-meter race, given the values 12.5, 13.1, 13.8, 14.0, 14.3, 14.7, 15.2, 15.6, 16.0, and 16.5. Get the interquartile range to determine the spread of the middle 50% of the data. So first step again is to find the first quartile, but first we need to arrange the given values. So since the given values are already in ascending order, let's just rewrite it. So since we already rewrite the given values in an ascending order, we need to find the first quartile. So again, we just need to get or to determine the lower half of the data, which is in here. And the median of this lower data is 13.8. So with that, our first quartile is equals to 13.8. So next is we need to find the third quartile. So the third quartile is the upper half of the data set. It goes from 14.7 up until 16.5. So we just need to get the value of the median, which is 15.6. So that would be our third quartile. So to find the interquartile range, we just need to minus the value of third quartile and first quartile. So 15.6 minus 13.8. So this equals to 1.8. So the final answer would be first quartile is equals to 13.8. Third quartile is 15.6. And for our interquartile range is 1.8. So the interquartile The scores of 12 students are 18, 25, 40, 35, 30, 45, 60, 55, 50, 70, and 75. So she